Okay, next presenter, Dr. Cornelis van der Waal, on a review and consolidation of Namibia's bush thickening maps. We will have some questions afterwards, so please listen carefully, because I printed out a couple of the big maps, which we can hand out, but it will be if you answer the question correctly. Cornelis, ecologist, active in the fields of rangeland management, restoration, biodiversity assessment, researcher, lecturer, trainer, practitioner, and he's been active in Namibia since 2010, and he runs and publishes the Rangeland Monitoring Early Warning System on the updating of the carrying capacity in Agri-Ecological Zone maps of Namibia. He's got a Ph.D. in Resource Ecology and lives with his family.
Thank you, Yvette. Okay. I see we are a little bit behind time, and if my wife listens to my WhatsApp, voice messages, she normally put it on 2 times, normal speed, because I talk so slowly. So I'll try to speed up a little bit. Okay, so if we look at these different pictures that you see there, I think we will have very little trouble to agree that, the main picture on the top, is representing a bush thickened state. And maybe also the small one. But if we go down to the low one, I think we will start having debate. Is this really a bush thickened situation or not? And that was exactly the problem that our team had to grapple with. Where do we decide what are the thresholds where we will have bush encroachment or bush thickening? So luckily, we had a really competent team. We had excellent project support from the Perry Wiley team, and we had a very understanding funder, which also made it very clear what they want from this very short-term consultancy. Only 3 months that we had to basically update the previous products that were available and that were created by SAIA in 2016. And here you can see a picture how that looked like. It was mainly based on the tree atlas information and then expert opinion. And I just want you to keep this in mind, the 45 million hectares affected that they came to for the total area bush thickened in Namibia. So our terms of reference was very clear. The first was to consider and review all the existing maps and information that were out there. Secondly, to make use of remote sensing information as far as possible and validate that with actual data. We didn't create any primary data ourselves, so we made available, or we made use of what was already available. And then very important was to base the final maps on consensus reached amongst representatives of stakeholders and industry. More about that a little bit later. So we've adopted the definition of bush thickening by that is in the current National Strategy on Sustainable Management of Bush Resources. And that basically just copied the Nico de Klerk definition that defines bush thickening basically in terms of its negative impacts on ecosystem services. But it does make clear in the statement below that forests as defined by the FAO are excluded from bush thickened areas. And if I just take you back to this previous map, you can see the far northern parts of Namibia were not indicated as bush thickened in the previous map as well. I think I'm going to skip over this one. It just indicates how difficult it is to find consensus among different ecosystem services with where exactly can we start talking about thresholds of bush thickening happening. Also keep in mind, we are working from dry woodlands in the northeast all the way down to shrubby arid lands in the south, and we need to map all of that in terms of where we consider bush thickening starts to happen or not. So eventually, jumping to the methodologies, we end up with basically two approaches. One in the northeast and then the other one in the south and west of the country. So in the northeastern areas, we basically based it on actual field data where we, not us, but previous projects, collected plot level data on tree cover, and then in a GIS we could extract what was the long-term rainfall for that area. And that's basically the graph that you can see. And what's interesting there is you can see the dots are all over the place, but look at that constraint that's placed by a rainfall on the upper level, that gray line that you see at the top, this line. So clearly, and that's also shown in many other studies, also this insert that you see at the bottom left, continental study in Africa, where they saw exactly the same thing. Tree cover is ultimately limited by moisture availability. So we assumed that this means that that upper limit is the total bush encroached or bush thickened situation. And then with quantile regression, we could also calculate, first of all, what the ceiling is, but then also what is the 25th percentile, which we then assumed above this line, we will have bush thickening starting to happen. So above that line, increasingly as you approach the ceiling or the 100% or 99 percentile upper line, increasingly that means, or we interpreted it to mean encroachment. So we used the long-term rainfall, and then we could basically look at the best data that we could get for tree cover was the bush information system that was initiated by the GIZ. And they only have data available, the latest data is 2018, so keep that in mind. But we could then basically look at what was the deviation from this threshold determined from the rainfall, and then what the bush information system tree cover showed us, in terms of how far it deviates from that rainfall line. And the darker green that you can hopefully see there means that it's more intense, approaching more the ceiling in the data than the lighter green areas. So this was for the north-eastern parts, but it didn't work so well in the south and west. So here we relied on the European Space Agency's land cover data for 2021, and they have different cover classes, of which the shrub layer is one of the layers. And the darker orange that you see basically indicates the shrub, and the yellow, the grass layer. And what we did is, this is at a 10-meter resolution, and we aggregated that to a 500 by 500 meter resolution, and we determined what was the proportion of shrub cover, in those larger pixels. And we could do it then, for the whole western and southern parts. And here are just some pictures from Google Earth that shows, some areas where you can see it's much more open, less shrubs, and it came out as grassy here, while all the rest you can see was classified as shrub. Also with the dunes, the dune crest more grassy, and then the dune streets covered by probably rygosum, much denser. We also included, and I'm happy to see Leon there at the back, Leon Libber's data from his work at the Ministry of Agriculture to adjust in some areas this information that we had. We then combined the two maps, the northeastern and the south and western one. With expert opinion, we adjusted some of the obvious changes that took place. Remember, the northeastern data is 2018, so a lot of changes took place in the meantime. And we also did some spot checks using Google Earth and also the satellite radar data for 2022. And the bush information system used in the northeast actually also used the satellite radar data, but of course for 2018. So we also delineated the forest because that needs to be excluded from the thickening layer. And for this we used the recent forest data layer from the Directorate of Forestry. And this is based on remote sensing work done by consultants. And they use this GEDI data, which is basically a satellite LiDAR system. Here you can see just for the north central parts of Namibia, the Kavangos, Oangwena, or Shikoti, where most of the forest, as defined by FAO, are situated. Just some of the pictures how we arrived at a more general product here at the bottom from the original raw data. We also, or the team also created this high-value timber species line. There's many of these areas we have, some of these, really important and very often protected species, and we just added this line to provide additional information. And we also updated the current encroacher species distribution maps for the what we considered 8 most important encroacher species. We started with model data from the Bush Information System, which use a model that basically used the tree atlas data and then look at environmental variables like climate, soil, and topography, how that explains the probability of occurrence of that species. We validated that information with a lot of new data that we obtained, and then also finally adjusted with expert opinion the distribution of these species. For instance, Mupani, according to the model, occurred in the Karibib area, and with expert opinion, we could move it north to its current distribution range. Consensus building, this received a lot of attention because it was deemed important from our funder to create robust products that are acceptable to most people in industry. First of all, we established a working group of volunteer experts and industry representatives. We had 3 working group meetings. The first meeting we presented very raw draft map products, and then there were some iterations where we every time work in the new feedback from them and in a new version and so on. There were also questionnaires that we obtained very specific information about, for instance, the content, additional content on the maps, formatting, what should be included, what not, and so on. And then we had a lot of individual contacts with farmers and also other experts with regards to the base layer validation. And we also then, after all these steps were taken, we also presented to the Directorate of Forestry Management, because they are currently the custodians of these products. And we incorporated their preferences and also feedback. So I think by this time we would really like to see the products. So this is the main poster product that we created. I just want to point out a few features, but I understand, do you have them here, Yefet, the maps themselves? Okay, so then you can have a close-up look at the actual product. I just want to point out, again, the green shades that you see, the dark green means the highest intensity of bush encroachment or bush thickening, and then the steps, the lighter shades, meaning that it's less intermediate, and then the lowest one that is lightly encroached or it's very isolated, the bush thickened areas. White basically means that we don't expect any thickening in those areas, or it's very isolated, just pockets that we can't map at this scale. Then there are a lot of other information on the poster. On the left bottom corner, you can see the distribution maps of 8 of the most important encroacher species. We have a lot of these small maps on the right bottom side that gives additional information. And then right in the bottom right corner, you see the statistics. The surface areas that we calculated were covered by all these classes within every region of the country. And then there's a lot of text. It's quite dense. I will not read it to you, but you're welcome to have a look at the actual products afterwards. It just gives the purpose, disclaimer, what it should not be used for. It should not be used for day-to-day management. This is meant for high-level strategic planning. And then it gives some information about bush thickening, much of what we heard already today. And then also the current regulations, summary of that. You know, what should you do, who should you approach, what's allowed, what not, and best practices and so on. Here's just a little bit of a zoom in on the distribution data of the different species. And then we came up with a final figure of 46 million hectares in some way or another affected by bush thickening in Namibia at the moment. And that means basically 65% of the land surface area covered. And remember, this is very similar to that 45 million hectares that SAIA in 2016 came up with. But take into account the differences in methodology. So I don't think we can directly deduce from that there was only a 1 million hectare increase in bush thickening happening. So in conclusion, our task was to update the previous 2016 product. We included a lot of remote sensing information and also made use of existing field data that was available. And because of doing that, we could add a lot of resolution to the previous map. We also followed a consensus approach, and I hope that we came up with a robust product. Of course, this is not static and needs to be repeated in a couple of years. Then where can you get these products if you don't win the quiz that Evert was mentioning? You can go to the Environmental Information Service in Namibia, their website, and then just search for bush thickening maps. You will get a whole list of all the information that I've showed you here, as well as the final report of our project. And thank you for listening, and thank you very much for the team, and also Evert for your team that you supported us during this project.
Thank you. Thank you so much, Cornelis. I want to reiterate something. Just put the map back up, because the question has been coming multiple times. Just to reiterate, dark green does not mean most biomass in terms of tons a hectare. It means from an environmental perspective, it's most encroached or furthest from what it naturally would have been. And that's why in the south you can have severely dark green, but it's just trichosa. Because relative to what it could have been, it's severely encroached. And you can't compare the amount of biomass. If you want to do charcoal, biochar, whatever, you can't use this. This is not what it's about. Just you. Questions for Cornelis? Oh, we need a question. Oh, it's embarrassing. Yes.
Yeah, thank you very much, Doc. If I look at your map, I see the western side of the country. Say, for instance, lower than 300 millimeter of rainfall. There's the increase in bush encroachment. Is it depending on the rainfall, or is it a matter of swells and topography.
Thank you, Josephat, for that question. Yeah, no, that's a difficult question, but remember that graph that I showed, with the upper limit, that moisture availability showed. So that means if you take an encroached situation there, it will look fairly open if you compare that, in the west with, let's say, the northeastern parts. So that's why on our map it comes out, it's negatively influencing the ecosystem services like grass production and so on. But the total cover might be far lower, than you will expect, in the east. So you have to look relatively at it. I think what caused that, it's, what we heard this morning, from Prof. Nico Smith, all those factors, and it's multifactorial and they interact with each other. What we learned from late Dr. Dave Hubert is that, even fires had an influence, in that low rainfall areas. But I think it's the old story, disturbance created by us and our management and so on. And then maybe a little bit, CO2 fertilization that helps the process along.
Thank you very much, Mr. Cornelius, for your presentation. I just want to understand more on the ESA product and the GIZ product. Did you use the GIZ product for accuracy assessment against the ESA product, or how was the combination between the two products, and what is the accuracy of the GIZ product? Thank you.
Okay, the GIZ product, you are meaning the Bush Information System, the BIS?
Yes,
right?
the product from there.
Yeah. Okay, I don't have the accuracy figures, in my head, but it was published, during the project time, and there was also a publication afterwards. But it was, if I remember correctly, in the 76% variance explained. They used actual LiDAR data, that I think Nampower generated, to calibrate and validate their product. The ESA land cover product, I'm not sure if it was ever validated in Namibia itself, but we did a little bit of validation ourselves, using Google Earth, like I showed, some of those pictures. But I can't say, what's the accuracy actually.
Okay, thank you.
Thank you. Okay, so here's a free map for the person who can tell me what was the name, the year, and the number of hectares that the previous map had. Okay, what was the name or the year? 45. Yeah, okay, there you go. There you go. Okay, but I have many more maps. I don't have enough for the whole audience, but let's say we'll hand them out as we can at the end of the day. So if you stay, you can get a map. But otherwise, these maps are also just available for download. Yeah, it's free of charge. It's from that website, or it's from our website. It will be available as well. Liz?